tal, amigos? El día de hoy estamos aquí con nuestro amigo Lake de Estados Unidos. Es un especialista en lubricación con ya bastantes años de experiencia y especialista en lo que es NASCAR y vehículos de competencia. Y pues el día de hoy está con nosotros compartiendo su tiempo porque vamos a contestar algunas preguntas que ustedes me han hecho sobre mitos de los lubricantes. So let's go ahead. This is my friend Lake Speed. Can you tell me about yourself? What are you doing?
Para no no hablo español, but I'll speak in English instead if that works.
Yeah, no problem.
After, I don't think 3 or 4 years, you think it through high school and college, I would have remembered some Spanish. I can read it okay, but as you just saw, I don't speak it very well at all. But fortunately for what I was doing in my career, I really didn't need it. I was, very fortunate that my dad, Lake Speed Senior, was a NASCAR driver and competed in NASCAR for almost 20 years. And several of those years, he actually had his own team. And what's interesting, a lot of people don't know this about my dad, is that in 1978, he was the only American to ever win the World Go-Karting Championship. He actually beat Ayrton Senna head-to-head in 1978 for the World Karting Championships. In fact, if there's anyone out there watching that's a big Formula One fan, if they've seen the movie Senna, the very opening sequence is the 78 World Championship in Le Mans that my dad won. So anyway, a little backstory. But so growing up around racing and being a part of the NASCAR community, I was very fortunate in 2004 to go to work for Joe Gibbs Racing. So Joe Gibbs Racing is one of the biggest NASCAR teams in NASCAR and has won many, many championships. At the time that I went there, they were in an interesting development phase. One, the money going there in NASCAR was getting really big, so the development budgets were just ballooning, and so there was a bit of a space race in terms of engine technology, which was a great time to be around that. We were also extremely fortunate to have a development partner, a company called Lubrizol. Most people who are not in the lubricants business have never heard of the company called Lubrizol. But, and the story goes, so NASCAR, up until only a few years ago, still ran a flat tappet camshaft. So actually I can show you one. So many engines you have like an overhead cam, you have a spring bucket, and it goes over it. Well, in NASCAR, we actually had a push rod engine. So you had 2 overhead valves actuated by a rocker arm, and there's a push rod. Well, as opposed to having a roller follower to roll on the camshaft, we had to use these things, these little flat tappet lifters. This is a DLC coated tool steel flat tappet lifter. And that was the Achilles heel, those in the valve springs of those engines. That was a limiting factor. So we had a lot of wear on these flat tappets. In fact, in 1999, Bobby Labonte was driving for Joe Gibbs Racing, and he finished second in the championship that year. The reason he finished second was he blew up 2 engines during races. Both of them were failed lifters. So we were having this problem. We hadn't had the problem in the past. But in the past, Shell had been one of our sponsors on the car. So Shell is a joint venture partner with ExxonMobil in a company called Infinium. So Infinium is one of the 4 companies that actually makes the additives. So you think about a quart of oil. We'll call it, 85% base oil, 15% additives, give or take a little bit. So there's only a handful of companies that make base oil. There's even a smaller group of companies, just 4, that really make the additives. The majors. There's some other people, but majors make the additives. So that's Lubrizol, Afton, Ornite, and Infinium. Right. So of course the Infinium folks have been working with Shell, and what we received from Shell while we were sponsored was a custom blended product made specifically for racing. It wasn't an off-the-shelf oil that was doctored up with more zinc or something in it. They actually had engineered a additive package specifically for the race teams, and we used it, and everything was great. Well, then when Shell got out of NASCAR in 1998, we didn't have that oil anymore. So we had those problems during the 1999 season because we didn't have this oil anymore that we had inadvertently been building our engines around. So we learned the hard way. We were fortunate through General Motors. We were a General Motors team, a sponsored team, that we were able to make contact with Lubrizol and explain to them our problem. They said, no problem, we know how to fix that. They began working with us, and we really began to see all the possibilities of applying tribology, the study of friction, wear, and lubrication to racing engines could do. So the first thing was we solved our flat type at wear problems. And in 2000, using the Lubrizol products, we won our very first NASCAR championship. So here's a little fun little stat. So in the 8 years prior to working with Lubrizol, Joe Gibbs Racing won 16 races and 0 championships. And the 8 seasons following the beginning of the development program with Lubrizol, we won 84 races and 5 championships.
84.
From 16 to 80.
From 16 to 84.
Yep.
It's a huge one. Change.
Yes, it is more than a statistical anomaly. And when we really began applying, I said, the science of tribology to these race cars, where we were doing, the break-in oil, the race oil, we had qualifying oils, we had shock fluids, gear oil, transmission, everything we could fluid-wise touch, and that greases. We did everything we could to try to make that car faster or more durable. And we were able to achieve a lot of success doing that. And then during that process in 2004, so we were 4 years into that cycle, the guys at Lubrizol convinced us that we should begin to sell the products we were making to other teams, which seemed very counterintuitive to a race team that's trying to gain an advantage. But they were pretty persuasive in their argument that the market was so large that whatever advantage we could, it was worth our while to make available to our competitors technology that we had already proven, because they would buy it. It would give us the money to be able to do more testing and more development. So we would always have an R&D product that was a step ahead of our competitors. So when we brought it to market, we could say, hey, this is better than what we've been selling, and we've been using it, and here's the proof. But it was still better than anything else they could buy. So they're going to buy it. We get their money. And now we know that money that they're spending on that product, they don't have an advantage on us in those areas. Oh, well, that's kind of good. Yeah, if we lock their resources and we know where they are, and they can't have an advantage on us in those areas, and we're technically ahead of them, that's a win. So we agreed to do it. And that's where the Joe Gibbs, now it's called Driven, product range came from. And I was very fortunate to be part of that team. I was employee number 1 in that department back in the day. And we were able to do a lot of neat, fun things. And over the years, we developed it, and we ended up formulating a lot of really incredible products that won a lot of races and won championships, even outside NASCAR. I couldn't even begin to count how many championships we've won beyond just NASCAR itself.
Excellent. That's interesting story. And you are the founder of the technology of the oil.
It was good to be I didn't start in that position. I had to work my way up and get there. But in the end, we ended up pretty much, I think everything they sell, everything they sold when I left, I had formulated. There wasn't anything left. I got my hands and everything by then. But it was fun. You know, we had a really great team of people at Lubrizol, Michael Musha, Doug Jane, Bill Abraham, Sarah Kipp, Claudette Cook-Lucas, Jim Dolio, Tim Thomas. There's a great little group of people there. Nathan Valentine. There were some great folks at Lubrizol that they poured into us. They were just as excited about trying to win races and win championships as we were. And it was fun to formulate products when no one cared what it cost.
Yeah.
It didn't matter what it cost. It didn't matter how much you were going to sell of it. It was like, let's make this and let's go try to win a race. Let's go try to win a championship. And then we'll worry about all the business stuff later. Yeah, that was fun. I realize now later in my career how unique that was.
like a no limit. You have all the resources. You can test it and do whatever you want. This is a great.
It must have been kind of like what the NASA scientists had when they were going to go to the moon, right? You just get to the moon. Yeah. It didn't matter. Just go to the moon.
Doesn't matter how much you need. $1 million, $2 million, $3 million. Nobody cares.
I'm looking at a copy of an article that came from the Wall Street Journal, 2009. It said $10 million just for motor oil.
It's a lot of money, right?
Well, you had to add it together over many, many years, but that's the reality of it. We looked at it in 2009. So that was about 10 years into this program. We looked at it and said, we're spending about $1 million a year just in engine testing, right? Because if you think about a NASCAR engine, even back then, those were $50,000, $60,000 engines. And so when you were testing, 5 or 6 engines a year, it's pretty easy to come up with, $300,000 worth of engine costs.
Yeah, for sure.
Just to test engine oil, right? Well, that's part of the cost of your oil program is the testing. And then let's say maybe you used $100,000 or $200,000 a year of specialty blended oil. Well, okay, that's $500,000 pretty easy. All right, well, you start doing that up, and maybe some years expenses are more than others. It doesn't take very long to get $10 million.
Oh, yeah.
Man,
okay, so let's start with the first question.
Sure.
The people say that, what is the best way to select engine oils based on the weather conditions, extreme hot and cold weather?
Well, the reality is, all oils get thinner as they get hotter. So most people's mindset goes to, thinking about that high temperature. The trick is this. All oils get thicker as they get colder. Yeah. So where you can have the biggest problem actually is at low temperature, because proper lubrication is the 4 R's. Right oil, right place, right time, right amount. Mm-hmm. Right oil is essentially the right viscosity and the additive package, and it needs to be clean for the application. But if the oil doesn't get where it's supposed to be, when it's supposed to be there, and enough of it, you can have a problem. So if you're in a colder environment, very cold, especially over the wintertime, that's where you need to make sure you have an oil that can flow well enough at low temperature so that you have enough oil at the right place at the right time. That's what we see can be an issue, especially in any kind of competition like drag racing and stuff. We've seen 25 horsepower difference because someone put in too thick of an oil, so they lost 25 horsepower because they, in their mind, I'm making 1,000 horsepower. I got to put in a 2050 or a straight 50 oil. Well, the reality was that engine may make 1,000 horsepower, but your engine might only be running, 40 degrees Celsius oil temperature. So at 40 degrees C, man, you could run a 10W30 and have tons and tons of viscosity still and be very, very safe and actually get better protection because you get better oil flow. because oil
Yeah.
isn't just a lubricant, it's also a coolant. So you need to have oil moving to take away the heat from the parts. I mean, we've run an engine on a 0W12 at 170 degrees Celsius oil temperatures and did not hurt the engine.
Yeah. That's what I checked in the new specs of the oils. They are thinner right now, like a
Absolutely.
016, 016,
Mhm.
020. This is the popular. I think it's gonna be the popular as well. The now in Mexico, the popular viscosity is 5W30
Oh, yeah.
and 5W40, and now the new cars it's zero. I think it's 0W20.
Yeah. We see the same thing. People have this hesitation to that lower viscosity grade, thinking that somehow or another that oil isn't going to be thick enough to
Yeah.
protect well. But the reality is, like I mentioned, when some testing we were doing for General Motors, this is 5 years ago, we came up with an R&D formulation that ran a 150-hour test at General Motors at 150 degrees Celsius oil temperature. And this 0W12 outperformed a 5W30 in wear protection in that test.
Oh, that's
Yes.
amazing. So people believes in Mexico, this is for example, and Latin America, when your car reach more than 100,000 kilometers, you need to increase the viscosity. For example,
Not anymore.
all right. So
Not
I
anymore.
think
So let me tell you why. Because most myths begin with a nugget of truth.
yeah.
Okay, so roll back the clock 30 years ago. So 30 years ago, it was pretty common to have tri-metal bearings, so copper, tin, and lead bearings that would wear away over time, and then also the piston rings in those engines would also be much bigger, thicker, higher tension rings. Maybe a thin ring back 30 years ago was a 16th, 16th, 3/16th ring. So what would happen with those big rings and those tri-metal bearings is over time the engine would wear. It would wear the cylinders a lot, the bearings would wear. So the older thought process of putting thicker oil in to compensate for the looser clearances that have been created because of how those parts have worn over time was actually logical. It made sense for those older, designed older metallurgy engines. But today's engines aren't anything like that. Yeah. Even an engine built 15 years ago will probably now have an aluminum bearing in it.
Yeah.
That aluminum bearing is much harder and will not wear the same way a tri-metal bearing is. Today's engines also have much thinner piston rings. It's very common from the factory to have a 1 millimeter or 1.2 millimeter ring, where again, 30, 40 years ago, it was a 2 millimeter ring. So you've cut the rings sizes in half. You've changed the metallurgy of the bearings. So, and the cylinders are actually harder materials now that hold oil longer. So it's a myth that you need to put thick oil in older engines today because the engines themselves are physically different. Not that they don't have pistons or anything. No, it's about the metallurgy and the surface finishes in those engines today are completely different than they were 30 years ago. So today's oil chemistry and lower oil viscosities can protect those modern components better because those engines are designed for it. So it's all about drawing that dividing line and understanding the old engine, really, really old engine, will treat it with the old way of doing it. Modern engine, don't do that old thing. It's not made for it.
Yeah, I say the people that even the technology change. They build the new motors, they build, for example, the manufacture of the oil, they need to change the formulations, the base oil, everything, because the new technology of the motors is changed. So now
Much
the
tighter
future is the
clearances.
lowest. Yeah.
Yes.
Lower oils.
Yep.
So the answer is use the fabricant viscosity that they say to use. For example, in my manual.
Yes. Yeah.
Right?
Just stick with whatever the service manual says. Just stick with that. Don't try to outthink the engineers at the OEM. Trust me, they know where you live, and they designed this to work in all conditions and environments. They test these engines in the very, very hot and the very, very cold. They know what they're doing.
That's perfect. So let's go with the second question. What happens if you add diesel engine oil on a gasoline motor?
Well, it depends upon what kind of gasoline engine it is. So a lot of today's engines, gasoline engines, are now direct injected, turbocharged engines. So if you have one of these DI turbo engines, putting a diesel engine oil in it can cause engine failure. The reason for that is that diesel oils typically have a higher detergent package. They'll have levels of calcium detergent in the oil because of diesels being sooty and all of that. Well, that calcium has proven to cause detonation, a special type of detonation. Gasoline engines called low speed pre-ignition, or LSPI. So you do not want to run a gasoline engine oil, run a diesel engine oil in a gasoline engine that's turbocharged, direct injected, for that reason. Inversely, you also don't want to run a gasoline engine in a turbo diesel, because the diesels make lots of soot, and the gasoline engines don't have the soot handling capability built in, so you can get increased cylinder wear. They call it bore polishing, that can happen in your diesel engine, because that gasoline engine oil isn't going to have the correct additives to handle the soot. So the real story is, if you've got a diesel, use a diesel oil. If you have a gasoline car, use a gasoline oil. Again, look at your service manual. The engineers aren't dumb. Just trust what they said. Follow the spec that's written in the book. Use that same viscosity, and then you're good.
Perfectly. So the next one, what is the difference between NASCAR and passenger engines?
Woo! They both have pistons. That's about where they stop. You know, they have pistons and crankshafts and blocks and heads, and beyond that, it's very different. So think about it this way. Tires is a good analogy. The same tires you would run in a NASCAR race or a Formula One race are going to be softer compound, slicks. They're designed for that, give you maximum grip for a very short duration of time. So a racing engine oil is just like that racing tire, whereas your passenger car tires are all-season radials, high mileage. They're designed to go 60,000 miles. So they're not going to give you the most grip, but they're also not going to wear out. And they can run in all different kind of conditions. Some snow, maybe some rain, and all this. They're having to deal with all these different variables. So that's like your normal passenger car motor oil. It has to deal with different fuels. It's got to deal with different temperature ranges and contaminants that are out there. That NASCAR oil isn't a better oil. It's a different oil. It's kind of like those racing tires. They're not better tires. They're just different tires. And the whole thing about oil is people are always looking for what's the best oil.
Oh, yeah.
There is not a best oil. It doesn't exist.
Yeah, correct.
Application always dictates chemistry. You want to use the right chemistry for your application. That will give you the best results. It's all about getting the best results. It's not about having magic molecules or the best oil. That NASCAR oil is designed for a NASCAR engine in the NASCAR environment. That's what makes the results better. It's not that the oil is better, it's that it's designed for the application.
So all dictation is the application.
Always, always.
Because yeah, you say this is the tricky questions. I think maybe in the world, what is the best oil? What is the best oil? Which brand is the best?
No.
Mobil is better than Chevron. Chevron is better than Castrol. Castrol is better than another one. I think it's the same. All the companies buy the same additives and they blend it. Depends of the
You think about it.
of the market, right?
So there's, if it's a PAO synthetic, right? So
Yeah.
PAO polyalpha type synthetic in North America, there's only 3 producers: Ineos, ExxonMobil, and Chevron Phillips. That's it.
Yeah, the base.
And then you got 4 additive
right?
companies. Yeah, but there's how many different companies out there selling, full synthetic oils, and they're making all these claims about how they're better and this and that. I'm like, are you buying? You go to Mars or somewhere else to get your stuff? Because I'm pretty sure you buy the same stuff from that everybody else buys. So what makes it better? It's not about it being better. It's about it being tailored to the application. It's no different than buying a suit, right? Anybody can go to the store and buy a suit, and you can put it on, and it could be a $1,000 or $1,500 Armani suit, but if it's not tailored and doesn't fit you right, it doesn't matter how much it costs. It's about having the right fit and it being tailored to you. That's right. What makes it work.
So, okay, fellows, follow the application. That's it. No more question about this one. So the next one, what is the modern way to determine the useful life of the oil?
What's the best weight for the...
Yeah, what is the modern way to determine the useful life of the oil? Because normally in Mexico and Latin American, they believe that the TBN test determine that you have to change the oil, right? Once you reach the 50% or 60 maximum percent of the TBN, you have to change the oil.
Well, so TBN is an interesting question. So if you have high sulfur fuel, which in Mexico, you may still have some higher sulfur fuel, like in the US and Canada, we don't. So TBN is not something that we should be looking at here in the US, because what really drives TBN is the sulfur content in the fuel. And that fuel dilution that gets into the oil creates sulfuric acids. That's what drives down the TBN. So depending upon where you are, if you're using a low sulfur fuel, low sulfur diesel or regular type gasoline, then it's not something you really need to worry about. But if you are using a higher sulfur fuel, then TBN is something to look at. And that old adage of, whatever your beginning value is, once it drops 50% of that, then go ahead and change it. That's not a bad thing to do. But you don't want to be blind to everything else that's going on. You want to look at the viscosity and make sure that the viscosity is not dropping you and going out of grade. You got to look at fuel dilution. That's one thing that I would say is more important than anything else in looking at the used oil analysis, is what the fuel dilution is. More so than TBN, more so than any other characteristic of it, is that when we see high levels of wear, it always correlates, 99 times out of 100 with a higher level of fuel dilution. So if someone's really interested in getting longer life or extending the drain interval, what I would highly recommend to do is do used oil analysis and keep a close eye on the fuel dilution. If you can keep that fuel dilution under 2%, then you can kind of trend it out and see what you can do. But if you're seeing more than 2% fuel dilution, I don't care what the TBN is. You need to change your oil, because you're going to have wear problems if you don't.
That's it. Simple. Okay, so let's go with the next questions. Is there any brand now on the market that lasts 20,000 miles?
Okay, well, if you're looking at something like maybe TBN, right, and you're looking at that and say here in the United States with low sulfur fuels, and if you're only going off of the where does my acid number and my base number meet, that's the absolute value, right? If you're using that as your metric, I'm sure there are some oils in some conditions that could make it 20,000 miles. But as we just mentioned, my argument to that is going to be, well, what's your fuel dilution? What's the wear rate in the engine? Because if you're only fixated on that one metric, you can lose sight of the bigger picture. Because to me, engines are more valuable. They're way harder to deal with and more expensive to replace than the oil. So I would rather have a shorter drain interval and make sure I have a lower overall wear rate in my engine than blindly try to just cut my maintenance costs and extend the life of my oil to the detriment of the life of my engine.
Oh, that's interesting. That's a great answer. I'm going to talk in Spanish. Entonces, pongan atención en los intervalos del motor. No tanto en el aceite, sino en su motor. So you say, put attention on the motor. That's it. Simple.
Yes. We make engine oil for the engines. We don't build engines just so we can put oil on them.
Yeah, because the expensive one is the engines, right? It's most of one of my friends tell me that I think one of the NASCAR motor is around $60,000, right?
They're about $85,000.
$85,000, yeah. Between 60 and 85. Okay, This is an expensive one. In Mexico, it's almost 2 million pesos. It's a lot.